Hola, mi clase. So we are doing 5.4, and I know that's a weird jump, but we are going to transform what's called a piecewise function, but we're going to transform our absolute value functions, okay? So this is what we would call the generic form for an absolute function, okay? So remember we had our parent function, which was just the absolute value of x, but then all of these letters can cause things. So we've seen A. A is what causes our compression and our stretch, right? So this is our, oh, I can't spell compression apparently. There we go. Or stretch. Okay. Now, this plus K, we also technically seen, right? This is going to move it up or down. I mean, it's actually going to move the vertex. Move the vertex. I'm going to put it that way. Move the vertex up or down. Okay. So that's similar to when we had plus B. It would move our y-intercept up or down. Notice it's still plus like that, okay? And then we have this last one, H, and for right now I'm gonna leave this, but we've seen this, now we're gonna kind of see what this is, and then I'll come back and add our last little note for this H. Okay, so remember A is our compression or stretch, it's our coefficient that causes that. Our plus B is the same as our y-intercept, it's what moves our vertex up or down, which we've also seen. So here is our table, and our function is absolute value of x in -4, and it's our function h of x, okay? So just like on that first video, we really can kind of pick whatever numbers we want. Based off this equation, we should be able to know, like, is it stretched or compressed or neither? We should know if it's opening up or down, okay? And now we're going to be able to decide if it's been moved up or down, and then we're also going to see what that H does, okay? So we need to make sure we can graph these. Oh, sorry. All right. So I'm going to plug in, sorry, I'm trying to get my pen back. Let's go -4, -2, like we did the first time, 0, 2, 4. Okay, remember I like to use the opposites of each other just so that it keeps it symmetrical and even. So I would go the absolute value of -4 -4. Well, the absolute value of -4 is 4, and then I'm going to go 4 minus 4. Well, that's going to get me 0. So we have the point -4, 0. So absolute value of -2 minus 4. Well, absolute value of -2 is 2. Minus 4 would get me -2. So we're going to have -2, -2. Absolute value of 0 minus 4. Well, 0 minus 4 is -4. So we get 0, -4. Absolute value of 2 is 2, minus 4 is -2 again. Now we have 2, -2. And absolute value of 4 is 4, minus 4 gets me 0. So we have the point 4, 0. So -4, 1, 2, 3, 4. Just want to make sure it's in the right pot. And then 2, -2. And 0, -4, and 2, -2, and 4, 0. So this opens upward because it's a +1 coefficient. It has not actually been stretched or compressed because the absolute value coefficient is 1. My A is 1. So all that's happened is my vertex has been shifted down. Okay, because of that -4. Just like when we had a -4 for my y-intercept, it's just a shift, right? It's a shift down because it's -4. All right, so our vertex is no longer at 0, 0, right? My vertex is now at 0, negative 4. I'm just going to add this into these notes. Is at 0, negative 4. My domain is still all real numbers. But my range is not just at 0 anymore, is it? It's actually now y is greater than or equal to negative 4. So that shift does affect my range, and it affects it by having my range be shifted down as well. Okay? And then our axis of symmetry is still perfectly at this y equals 0 in a sense, right? It's perfectly here in the center again, y equals 0. All right. So this one's a little bit different. This is where the 4 is inside the parentheses, or absolute value. I really shouldn't call it a parentheses. It's inside the absolute value, which then is going to shift this a little bit differently. Okay? And so I want to graph it and then have you guys notice what is that shift, what causes that number inside, okay? I do really quick right here. I said y equals 0. This is actually x equals 0, right? Because it's a vertical line. So my axis of symmetry is where x equals 0. All right. So yes, let's use negative 4, negative 2. These are my faves. 0, 2, 4. So we're going to do absolute value of negative 4 minus 4. But we actually have to do this stuff first. So it's going to be negative 4 minus 4. Well, that's negative 8. Absolute value would be 8. Okay, so I would get negative 4, 8. And then if I do 2, I'm going to go negative 2 minus 4. Well, negative 2 minus 4 is 6. Well, negative 6. And then absolute value would be 6. So we get negative 2, 6. Same, we go 0 minus 4. Well, that's negative 4. But if I take the absolute value, that's 4. So I get 0, 4. And then 2 minus 4 is negative 2, and then I actually get 2. Now, see, notice this. This is not the exact same anymore. So we cannot just find, the negatives and pop them into the positives, because when I plug in 2, I actually get 2, not 6. And then the last one, 4 minus 4 is 0. Absolute value of 0 is 0. And so I actually get 4, 0. So I can't graph for negative 4, 8, doesn't fit, but I can graph negative 2, 6, and I can graph 0, 4, and I can graph 2, 2, and I can graph 4, 0, and I just realized we don't even have another point on the other side for our V, so let's add 6. Let's add 6 here. So if I go 6 minus 4, that's going to get me 2. Absolute value 2 is 2, and we have the point 6, 2. And there's my other side of my V. This one. So here's one side of my V. And then I need this to move. Here we go. Other side of my V. So we can see now it hasn't been shifted up or down. This actually shifts my vertex left or right. And it's similar to when a while ago we were doing those opposites, right? Point slope form, when it was inside the parentheses, it was the opposite, right? We had parentheses x minus 2, the point really was 2. So it's similar to point slope form, where inside those parentheses, it's technically kind of the opposite. Because if this is minus 4, that's really negative 4, but it happened to end up at 4. Okay, so this inside number, I'm going to go back to the beginning. This is a movement. It moves the vertex left or right. Okay, so all of these things transform our parent function. Okay, so now my vertex is at 4, 0. Okay, my domain actually is still all real because it's going to continue both directions. It's just starting at a different spot. And then my range, in this case, is just y equals greater than or equal to 0 because it doesn't drop in the negatives. And then my axis of symmetry has been shifted as well. Here's my axis of symmetry. And so my axis of symmetry line is where x equals 4, right? That's that line right there. So just like my vertex shifted, so did my axis of symmetry. Alrighty. How about I pick some numbers for you? Let's do -2, -1, 0, 1, 2 this time. See how these go. We'll see if we get both sides. And then I want you to fill them in and graph them and see if yours matches mine. So this would be a good time to pause and fill these in and graph them. So -2 plus 2 is 0. 0 minus 1 is -1. -1 plus 2 is 1. Absolute value of that is 1. Minus 1 would be 0. 0 plus 2 is 2. Absolute value is 2. 2 minus 1 is 1. 1 plus 2 is 3. Absolute value is 3. Minus 1 would be 2. And 2 plus 2 is 4. Absolute value is 4. Minus 1 is 3. So we got -2, -1, 1, 0. Uh-oh, I don't have my other side, so I'm going to have to put maybe another negative or 2 in here. 1 was at 2 and 2 was at 3. Okay. Let's put -3 and maybe -4 and see if we can get that other side. So -3 plus 2 minus 1. Well, that's -1. Absolute value is then 0, right? Absolute value is 1. 1 minus 1 is 0. So there's my other half, -3, 0. Let's just put 4 in just because I already wrote it down. So -4 plus 2 is -2. Absolute value is 2. 2 minus 1 is 1. Oh, close that. So you can see there's my other side. So 3, 0, and then 4, 1. All right. Graph my V. My dots don't line up with my graph as nicely. That's okay. All right. Vertex is at -2, -1. Now I want you to notice, -1. Look at opposite of this is -2. Opposite, or the actual number of this is here. It's just like point slope. This was my vertex right here the whole time. There's my vertex, just the opposite of the x and then the actual k. So h and k make my vertex. The opposite of h and k make my vertex. Okay. There's no coefficient, so I know that this is not stretched or compressed, right? So there's my vertex. My domain is going to still be all real because it's going to continue from here all the way over here and continue from here. But my range is now y has to be greater than or equal to -1 because my vertex has been dropped. See, down 1, left 2, because it's the opposite. So your vertex is actually in the equation. And then our axis of symmetry line is right here across my vertex. And that's where x is -2. So x equals -2 is my axis of symmetry. Okay, so before we start this, let's see if we can figure out where our vertex should be. Well, my h and my k are both gone, so since I don't have them, it should be here, which would then make my axis of symmetry can't spell, good luck. I totally spelled that wrong. I'm just going to put axis. Should be at x equals 0, because if you notice, it's always where my vertex is. So my vertex here was 0, 4. Notice, oh, this should be -4. I'm going to fix that. My axis of symmetry was x equals 0. Okay. Here, my x was 4. My axis of symmetry was x equals 4. Here, our third question, x equaled -2. That was my vertex. Okay. And then I want you to look, we could actually say something about the range as well, because notice my y on my vertex is -4. That's what my range was. Okay, my y on my vertex was 0. That's what my range was. My vertex here was -1. There's my range. So our domain can also probably be listed, right? It's going to be all real. And then my range can be listed. It would be y is probably going to be greater than or equal to 0. Okay, but now we have an a. Remember, this is my a, so is it going to be compressed or stretched? Okay, so greater than 1, it will be stretched. Less than 1, it will be compressed. So -4, -2, 0, 2, 4. Got it, I got it. 2, 4. So I'm going to go half the absolute value of -4. Absolute value -4 is 4. Half of that is 2. So this is at -4, 2. Half the absolute value of -2, that's 2. Half of that is 1. We get -2, 1. Half of absolute value of 0 is 0. Half of the absolute value of 2 is 1. And half the absolute value of 4 is 2. So 0, 0, 2, 1, 4, 2, -2, 1, -4, 2. And you can see it has been compressed, right? Because it's been smushed down. Compressed. And look, we were right. There's our vertex, 0, 0. Our axis of symmetry is where x equals 0. That's right here. Right? And our domain is all real, and our range was y is greater than or equal to 0. So notice I got all this information just from this equation before I even had to go graph it. All right. So I'm going to leave this one for you guys to do. I want you to list the domain, the range, the vertex, the axis of symmetry, whole shebang. If you need to make a table, you can. Just remember some of this information is right here, okay? But try to visualize what it's going to look like, right? What is -2 going to do to it? What is -1 going to do to it? What is the 4 going to do to it? So think about what those numbers are going to do before you graph them so that you have an idea of how it should look, okay? And then list these: domain, range, vertex, and axis of symmetry. And then this one I'm actually going to have you do as well. I want you to write it in function notation, so we'll go f of x equals, and then you need to write the equation that would work for this graph, so it needs to look something like this, right? Vertex has been shifted. How has it been stretched, or has it been compressed? Okay, so you're going to write the equation. Okay, so these are the two I'm leaving blank for you. and we'll talk about them when we get to class. Kind of think of them as their independent practice. So here's all the main things to remember. It's just broken down for you a little bit more. It says the graph of g sub x is a absolute value of x minus h plus k is transform of a graph of the absolute value function f of x equals absolute value of x. So remember, this is what we call our parent function, right? This is our parent function. Anything we do to that is then a transformation of it. So that's our beginning parent function. So adding a constant h is going to translate the graph horizontally. Adding a constant k is going to move it vertically, right? Horizontal left and right, vertically up and down. Multiplying an input of a constant a greater than 1 is a vertical stretch. Multiplying an input of constant, right, if our a is less than 1, it's going to be a compression. And then it says when a is greater than 0, the graph of the function is less than 0, the graph is reflected. So that's when it's flipped over, right? It's upside down. Where you guys made fun of me today. All right, so that's it. You have 2 independent practice problems. These are kind of more of a breakdown of what we wrote at the beginning. And then, yeah, that's it. All right, adios until next time.